We're now going to look at some examples of questions that uses the discriminant or delta. We first look at numerical problems. That means problems where all the coefficients of x are numbers. So in this case, for instance, if you quickly look, you will see that we've got just the numbers 3, -2 and 8 other than x here. First question reads, determine the nature of the roots of 3x squared minus 2x plus 8 equal to 0. You first have to decide what are the values of the a, b and c that we need for the formula for the discriminant. A is the number in front of the x squared, so a is 3. B is the number in front of just x, so that's -2, and c, or the constant, is the number without x, so c is 8. We now write down the formula for the discriminant delta equal to b squared minus 4ac, and then we substitute the letters that we got in the previous step. So b -2, so b squared becomes -2 all in brackets squared. It's imperative to put the brackets around both the negative and the 2 here, otherwise your answer will be wrong. Then -4 times a times c becomes -4 times 3 times 8. -2 all in brackets squared becomes 4, and -4 times 3 times 8 becomes -96. 4 minus 96 is -92, which of course is a negative number or less than 0. That means that the roots are non-real, or this parabola will not have any x-intercepts. Question 2, determine the discriminant of 0 is equal to x squared plus 8x plus 16, and hence comment on the nature of its roots. In front of the x squared here we see nothing, but you should know that that means that there is a 1, because we can omit the 1. So a, the coefficient of the x squared, is 1, b, the coefficient of x, is 8, and c, the constant or the coefficient without x, is 16. We substitute these into the formula for delta, and we get b squared becomes 8 squared. -4 times 8 times c becomes -4 times 1 times 16. That leads to 64 minus 64, with the final result 0. Now, if delta is 0, that means the roots are equal and rational, or there is just one x-intercept. Number 3, comment on the nature of the roots of 0 is equal to y squared minus 5y plus 4. In this case, we've got an equation in y instead of x, but that doesn't make a difference. The equation can be in any variable. The number in front of y squared, or a, is 1. The number in front of y is -5, and the number without y is 4. So a is 1, b -5, and c 4. We substitute these again, so b squared becomes -5, the negative and the 5 all in brackets, squared, -4 times a times c becomes -4 times 1 times 4. That leaves us with 25 minus 16, or 9. Now 9 is a perfect square, so it can be written as a rational number squared, in this case 3 squared. As delta is positive in a perfect square, so delta perfect square, and the roots are rational and real in brackets there, and distinct. I put and real in brackets because it's actually not necessary. All rational numbers by definition are real, so we could just put there rational and distinct. Distinct, just another word for different or unequal. The last purely numerical problem there, what can you say about the roots of -3x squared minus 3x plus 2 equal to 0? The coefficients here, the number in front of x squared, or a, is -3. In front of x we also have -3, so b is also -3, and without x we've got 2, so c is 2. Then the discriminant equal to b squared minus 4ac, that leaves us with -3 all in brackets squared minus 4 times -3 times 2, or 9 plus 24, which is 33. Unlike the previous number, positive 33 cannot be written as something squared, as a rational number squared. So thus delta is positive but not a perfect square, so the equation has two unequal irrational roots. In section B, we look at problems where some of the coefficients are constants. If you just peek ahead a little bit, what I mean with that is, for instance, there we've got k x squared and plus p. So other than x, it's not just all numbers anymore. We've got more letters of the alphabet. Let's start with the first one there. Comment on the nature of the roots of kx squared plus p equal to 0, where k is greater than 0, that means non-zero and positive, and p is less than 0, which means non-zero and negative. Notice here that there's no term in x or middle term. We fill that up by putting 0x. Since 0x is nothing anyway, we can do that. So we end up with kx squared plus 0x plus p, and we find the coefficients a equal to k, b equal to 0, c equal to p. And we go and substitute again into the formula. So we get 0 squared minus 4 times k times p, or negative 4 kp. The question stated that k and p had opposite signs. Therefore, k times p will be a negative number, less than 0. And then negative 4 times that negative number, and negative times a negative results in a positive. So negative 4kp, or delta, is greater than 0. So delta is positive and not 0. But we do not know if that number is a perfect square or not. So the roots may be rational or irrational, and you should know from number theory that together the rationals and irrationals form the real number system. So our final answer is that the roots are distinct and real. Last question. Given that q is not 0, state the nature of the roots of the quadratic equation 0 equal to qx squared minus 4q. Once again, we do not have a middle term there, so the coefficient of x is also 0, and the coefficient of x squared was q, and the coefficient without x was negative 4q. So that gives us a, b, and c. We substitute those into the formula for delta. B squared becomes 0 squared. Negative 4 times a times c becomes negative 4 times q times negative 4q. The two negatives times to give a positive. 4 times 4, of course, 16, and q times q squared. But that can be written as 4q in brackets squared, since 4q times itself would give delta in this case, which is 16q squared. So we have a perfect square here, and from integer sign rules it follows that any real number squared is positive or greater than 0. So we have a positive number, that means there's two distinct roots, but it's also a perfect square. So the final answer, delta, is a non-zero perfect square, so the roots are unequal and rational.